What if every night your brain took out the trash? Not metaphorically, not psychologically, not emotionally, physically. Picture a sanitation crew on duty while you sleep. Invisible workers moving through the corridors of your mind, collecting the detritus of a day's worth of thinking. Broken protein fragments, excess neurotransmitters, metabolic byproducts. They sweep away what would otherwise clutter the delicate machinery of neurons, preserving memory, protecting circuits, and helping to reduce long-term wear and tear that can contribute to disease. For decades, scientists thought sleep was mostly about rest, a pause in activity so the body and mind could recover. Today, we know something far more remarkable. Sleep appears to be a time of active housekeeping, one of the body's greatest detoxification processes. At the center of that discovery is an extraordinary network called the glymphatic system. Welcome to one of the most surprising findings in modern neuroscience. Chapter 1: The Brain's Garbage Problem. Every organ in your body produces waste. Your liver filters toxins, muscles release metabolic byproducts after effort, kidneys sift fluids, and your gut handles cellular turnover. The brain is no different, and in many ways, the problem is even greater. Although it makes up roughly 2% of your body weight, the brain consumes about 20% of your energy. Every thought, memory, emotion, and decision requires cells to fire, expend energy, and in doing so, generate waste. Left unchecked, that waste, small protein fragments and cellular debris, could accumulate and interfere with neural function. For decades, the puzzle remained. How does an organ encased in bone, lacking the obvious lymphatic pipes of the rest of the body, keep itself clean? Chapter 2: Discovering the glymphatic system. The answer began to come into focus in 2012 when researchers identified a previously unrecognized cleaning network inside the brain, the glymphatic system. The name blends glia, the support cells that help neurons, with lymphatic, pointing to its functional similarity to the body's waste clearance network. Imagine a plumbing system threaded through brain tissue. Cerebrospinal fluid, CSF, flows along these channels, permeates between cells, picks up soluble waste, and routes it out along specific drainage pathways. Astrocytes, star-shaped glial cells, help form those channels and guide fluid movement, creating a route for waste to be carried away. What made the discovery extraordinary was not just the existence of that plumbing, but when it works best, during sleep. Chapter 3: Why deep sleep matters. Sleep is not a single uniform state. Over the night, your brain cycles through stages: light sleep, REM, dream sleep, and deep sleep, often called slow-wave sleep or N3. It's during deep sleep that the brain shifts into its most restorative mode. In N3 sleep, electrical activity in the cortex slows and becomes highly synchronized, heart rate and blood pressure dip, and overall metabolism changes. Importantly, the spaces between brain cells expand. Researchers estimate this enlargement can be substantial, allowing cerebrospinal fluid to flow more freely through tissue. Think of it as city streets emptying at midnight. With traffic reduced, cleaning crews can sweep the avenues with ease. This nightly expansion and fluid movement create a biological rinse cycle, a regular, ongoing wash that clears away metabolic waste and helps maintain a healthy neural environment. Chapter 4: The beta-amyloid connection. One protein that has captured intense scientific interest is beta-amyloid. It's a normal byproduct of cellular processes, but when it accumulates in excess, it can form plaques associated with Alzheimer's disease. Studies suggest that the glymphatic system plays a key role in clearing beta-amyloid, particularly during sleep. The implication is simple but profound. Chronically poor or fragmented sleep may reduce the brain's ability to flush out such proteins. Over years and decades, diminished clearance could contribute to protein buildup and increased vulnerability to cognitive decline. That said, Alzheimer's and other neurodegenerative diseases are multifactorial. Sleep is one important piece of a complex puzzle, not a guaranteed prevention. Chapter 5: Your brain shrinks to clean itself. This may sound like science fiction, but the evidence is clear. During deep sleep, brain cells slightly reduce their volume, creating more space for fluid flow. Picture a crowded city where, for a few hours each night, people retreat indoors and streets open up for maintenance crews. That transient reconfiguration allows the glymphatic system to work efficiently, every night, for your entire life, a subtle physical reorganization to facilitate cleaning. Chapter 6: The Cost of Sleep Deprivation. What happens when we shortchange that process? When deep sleep is fragmented, curtailed, or displaced by late nights and chronic sleep debt, the consequences go beyond simple fatigue. Impaired sleep has been linked to poorer memory, slower learning, increased inflammation, changes in metabolism such as insulin resistance, mood disturbances, and slower recovery from injury or stress. Over the long term, insufficient sleep may also undermine the brain's nightly maintenance, raising the theoretical risk of accumulating harmful proteins. One missed night is unlikely to cause irreversible harm, but just as you wouldn't never empty your household trash, repeatedly neglecting sleep maintenance can create a gradual buildup that becomes harder to manage with time. Chapter 7. What controls deep sleep? Deep sleep isn't a matter of luck. Its quality and quantity are shaped by many factors. Consistent sleep timing, the integrity of your circadian rhythm, physical activity during the day, psychological stress, alcohol intake, ambient temperature, and exposure to light, especially in the evening. Age also plays a major role. As people get older, the proportion of deep sleep tends to decline, which may help explain some age-related changes in memory and resilience. That means protecting deep sleep becomes increasingly important as we age, and small lifestyle choices can make a big difference. Chapter 8. The HRV connection. At Oxyzen Health Intelligence, we often look at heart rate variability, HRV, because it offers a window into recovery and autonomic balance. HRV measures the variation in time between heartbeats. Higher variability generally reflects greater physiological resilience and better recovery capacity. People who consistently show healthier HRV patterns often report better sleep quality, and good sleep supports more effective deep sleep cycles. HRV doesn't directly measure glymphatic function, but it does provide insight into the broader biological environment that allows restorative processes to happen. In other words, the nervous system that recovers well at night is more likely to create the conditions the brain needs to run its nightly cleaning. Chapter 9. Building a glymphatic-friendly night. If deep sleep is your brain's cleaning cycle, how do you protect it? The strategies are deceptively simple and rooted in routine. Keep a consistent sleep schedule, going to bed and waking at roughly the same times. Seek morning sunlight to anchor your circadian rhythm. Dim lights and minimize screens in the evening to signal your brain that nighttime is coming. Limit alcohol and heavy meals close to bedtime. They can fragment deep sleep. Manage stress through practices that work for you: breathing, mindfulness, or brief movement. Make your bedroom cool, dark, and quiet to support deeper stages of sleep. Maintain regular daytime activity and exercise, which promote sleep drive without being overly stimulating near bedtime. Biology tends to reward consistency over complexity. The small, steady habits you apply night after night often produce outsized benefits. Chapter 10. The future of brain longevity. For decades, brain health has focused largely on treating disease once it appears. The future may emphasize preservation, protecting cognition before decline begins, preserving sleep before dysfunction develops, and supporting recovery before symptoms emerge. The glymphatic system reframes sleep not as idle time, but as active maintenance, an ongoing service that preserves the most complex structure we know, the human brain. Final thoughts. If there's one takeaway from today's episode, remember this. Deep sleep is not passive. It's active maintenance, active recovery, active cleaning. Every night, your brain performs extraordinary work on your behalf, clearing waste, supporting neurons, preserving function, and preparing you for the day ahead. One of the simplest longevity decisions you make every day is when you choose to go to bed. Sleep is not time lost. It is a biological investment. I'm Dr. Yendi. Thank you for joining me for another episode of Oxyzen Health Intelligence. Remember, tonight your brain has important work to do. I'll see you in the next episode.